Yeah. Hmm. Can you see my screen? So the
Yes, sir.
question is that the efficiency of the switching regulator. Okay. So what is the efficiency of the switching regulator? What is the formula for efficiency of the switching regulator? If you remember the formula for the switching regulator formula is, sorry, efficiency is, mm, efficiency formula is V out by V in into duty cycle. Okay. What is the V out? V out is a 1 volt. What upon V in? That is a 3 volt upon duty cycle. What is the duty cycle? Duty cycle is basically the T on time period divided by T on plus T off. Okay. So that is the 1 divided by 3 into. Now if we go with the question, yeah. So if we are saying that T on is from 5 to 7 and T off is from 7 to 10. Okay. So that means on time period is 2. Either the unit is second, millisecond, any unit. Okay. Because duty cycle is a unitless. It is a ratio of second upon second or time upon time. So it is a unitless. So T on is the 2 unit divided by T on is 2 unit plus T off. What is the T off? T off is a 3 unit from 7 to 10. Okay. So it becomes a 1 divided by 3 into 2 and it is a 5. So 5. So the efficiency is 5 by 6. Okay. Efficiency is 5 by 6. If we calculate the efficiency in percentage, so it is a 5 by 6 upon into 100. That is around 83.33%.
Got it, sir. Thank you so much.
Any other doubts? Question number 4. Practice assembly. I think rest of the questions is easy.
Sir, if you can upload the solutions for rest also, it will be useful, sir.
We can, but you are saying
Solutions for other questions also.
other question, practice question.
Yeah, yeah. If you can upload the solution, the text solution.
Solution for the graded assignment or the practice?
Practice, practice.
Okay, practice. Okay, I will do that.
Thank you, sir.
I think for the graded assignment, week 8, 9, 10, 11, solution is pending. Okay, so I will upload 8, 9, 10, 11 graded assignment. And for the practice assignment, I need some time because I have not solved that one. So I will solve them and after that I will upload.
Okay, sir.
Any doubt related to practice assignment, I can solve it here. Your graded assignment deadline is passed?
Oh, yes, sir.
Okay.
Just that we've been busy with labs, sir. That's why practice we couldn't do much.
For the lab, because of lab?
Yes, sir.
Okay.
Sir, graded assignment 10, question 4.
Graded assignment 10, question 4. Yeah, this one. I removed that one
Yes, sir.
from the evaluation part. Okay, but I will explain you. The question is that what is the variance of the output voltage is when the 0.33% in the R1 resistance and 0.5% in the R2 resistance. Okay, so the formula for the del V out upon V out. So del V out upon V out, it is equal to R1 upon R1 plus R2. Okay, we solve this formula in the our class. Okay, so del of R1 by R1 plus del of R2 by R2. Okay, so it is a R1 upon R1 plus R2. Now del of R1 upon R1 is given is the 0.3%, that means 1 by 3. Okay, 0.33. And del R upon R2 is 1 by 2, 0.5%. R1 square. Yeah, this is the formula. Okay, del V out upon V out. Okay, now R1 and R2 is not given to you, so we can't calculate the del V out upon V out. That is R1 upon R1 plus R2 square. Now if we calculate this one, so it becomes a 6 by 5 by 6. Okay, so it is a 0.83% of R1 upon R1 plus R2. This is a variation in the output voltage. Okay.
Yes, sir. Thank you,
Now, if
sir.
R1 and R2 is given, you can put the value of R1 and R2 and calculate what is the variations. So, the R1 and R2 is not given here. So, that's why we are putting the R1 and R2 in this one. Any other doubts? The question number 8. Any doubt in question number 8? Okay. I will solve the question number 7 and question number 8 both. What is the V out? V out, we are getting a 3.5 volt. Okay. So the question is very simple. V out is 3.5 volt. Here we are assuming the Vx, that voltage is again same here because it is a negative feedback. So apply the virtual ground concept. So the Vx both point is the same. Okay, Vx at the both point will be same. Now, if this is a 3.5 volt, so what is the current flowing from this one? Is 3.5 divided by the resistance, and total resistance is 120 plus 35. Okay, and what is the voltage at Vx point? Is the current that is flowing from this one multiply by this resistance. So multiply by 35k ohm is simply the Vx. Okay, so if you calculate the Vx value is 0.79 volt. Okay, Vx voltage is 0.79 volt. Now, in the second question, question number 8, what we are asking is, we are asking that now the output voltage is changed up to the 4.2. Okay, so this particular voltage, output voltage is changed 4.2. 4.2. So this particularly resistance I am saying the Rx. Okay, this resistance is Rx. Vx we know. Okay, Vx we know. We have to calculate the changes in the Rx. So again the value of current is what? Now it is a 4.2 divided by 35 plus Rx. Okay, this is the value of current. If it is multiplied with 35k, we are getting the Vx value, and Vx value is nothing but 0.79. So if we calculate this one, so 4.2 into 35 divided by 0.79 is what? 35 plus Rx. Okay, so it is a 35 plus Rx is what? It is around 180. 186.6 kilo. So what is the value of Rx? It is 151.6 kilo. Okay, 151.6 kilo. Now initially, what is the value of Rx? Initially, what is the value of Rx? 120. Okay, now it will be changed up to the 151.6k for output voltage 3.5 to 4.2. So del of x, what is the del of Rx? Is 151.6 minus 120 is equal to 31.6. So this is the change. Okay.
Okay, sir. Sir, can you solve the last term in term paper?
Last time in term paper. mm, It is available. Let me check. Uh, okay. Wait a minute. Yes, question number 1. Can you solve it? Yes, question number 1. Can you solve it?
So we have to find V out in terms of V1 and V2.
Yeah.
So first we have to find the voltage around the R4, na?
So first we are getting this is okay. First we are getting this one. Okay, so we can apply the equation.
Yes, sir.
Okay, so what is the relation between these two voltages at this point and this point is, if this is the input voltage for this one, we notice the input voltage for this one. What we are getting at this point is
Minus V naught upon RG
minus
upon RL.
Rg by Rf. Okay, can you apply the KCL for this complete term? Consider the V1 voltage. Apply the superposition theorem. First we consider the V1 voltage. Second time we consider the V2 voltage. Again apply the superposition theorem and calculate it. So you can try it. Give you 5 minutes. You can try it.
Excuse me, sir. Sir, I had a doubt in quiz 2's question 3 part A.
Okay, push to question 3 part A. Yeah.
Sir, I don't know how to find out mark the feed, sorry, this signs plus and minus of these op amps.
Okay. This one.
Yeah, yes, sir, part A.
Yeah. Part A. Or mark the sign of the operation amplifier. Now you can see here is that when we apply the Vi voltage, okay, we consider the DC. Okay, Vi as a DC. So if we do the DC analysis of that one, in the DC, this particularly path will be open. Okay. Similarly, this capacitor behave as an open circuit. Now, if we are talking about this loop, so this loop is not completed on the DC supply. This loop is open loop when we apply the Vi as a DC supply. Is it clear?
Yes, sir.
Okay, so which particular loop is completed? Lower one.
Yes, sir.
Okay, and generally what we do in the operation amplifier, mainly we work that operation amplifier will be the negative feedback. So that means if this loop is completed, we consider this is a negative sign and this one is a positive
Okay, sir.
sign. Okay.
Thank you, sir.
Yes, have you solved it?
Solving, sir.
Okay.
Sir, not getting the exact idea to
Hmm?
solve it. Not getting the exact idea to solve it.
Okay. Any other? Go try it. Any other who is trying that? No one is trying. No one is trying? Okay. So I'm going to take a screenshot. Wait a minute.
Sir, in the end term, there will be choices in the question.
No. There are 5 questions you have to complete, you have to calculate, or you have to answer all 5 questions. So now we are saying that if this is a V2 voltage, this V minus voltage is what? V2 times R3 upon R2 plus R. Okay. Similarly, this voltage will be happening at this point. So if I am saying this is a V plus voltage,
Sir, maybe your screen is not visible.
yeah, what you are saying?
Your
Screen is
screen
not.
is not visible.
Okay. Yeah, now it's clear.
Yes, sir.
Yeah. So we are calculating the V negative voltage, this point voltage. This point voltage is what? V2 voltage, it will be dropped across the R3. So V2 multiplied by the R3 upon R2 plus R. Okay. And that particularly V negative voltage is equal to V positive voltage because of negative feedback and virtual ground concept. Okay, now thing is that if you apply the V naught voltage, what you are getting at this point is minus V naught Rg by Rf. Okay, that is the negative voltage. That means what you are getting at this one is the negative voltage. Okay, now it will be multiplied with positive, so it will become a negative voltage. So you are getting a negative voltage. If you want to break a loop, okay, break it. If you want to break a loop, break it from here, increase minor voltage. Okay, like if you apply the plus 1 volt, okay, so it will be here you are getting a minus Rg by Rf. Okay, minus Rg by Rf, that means negative voltage. Now this negative voltage here you are getting again a minus Rg by Rf, multiply with plus, so it is again you are getting a minus Rg by Rf. Okay, so that means the voltage at this point you are getting is the negative. So that means this feedback is a negative feedback. Okay, this feedback is the negative feedback. Clear? Any doubt? So due to the negative feedback and virtual ground concept, this V plus voltage become equal to the V minus voltage. So this is the V plus voltage. Now apply the KCL. Now apply the KCL. So V1 minus V plus upon R1 is equal to, if I say that's the V2, so V plus minus V2 upon R4. Okay. And what is V2? If this is the V naught, so V2 is minus Rg by Rf into V naught. So if we apply this terms here, so V1 minus V plus upon R1 is equal to V plus minus, and V2 is Rg by Rf times V naught upon R4. Can I separate it? So V1 by R1 minus V plus upon R1 minus V plus upon R4 is equal to Rg by Rf into R4 times V naught. Okay, what is V plus? V plus what is V minus? So we are putting the V2. So V1 by R1 minus V plus R4 plus R1 upon R4 R1 is equal to Rg by Rf into R4 multiplied by the V naught, and V plus we are putting V2. So V1 by R1 minus V2 R3 upon R2 plus R3 into R1 plus R4 upon R1 R4 is equal to Rg Rf R4 times V naught. Can you solve it now? Take a R1 LCM, denominator time R1 LCM, and multiply this one. So it is a V1 minus V2 R3 upon R2 plus R3 multiplied by R1 plus R4 upon R4 is equal to Rg into R1 upon Rf into R4 times V naught. Okay, and in the question it is asking V naught. So what is the V naught? V naught is nothing but V1 Rf into R4 upon Rg time R1 minus V2 R3 upon R2 plus R3 R1 plus R4 upon R4 Rf into R4 upon Rg into R1. This is the final. Okay. Yes. Now next question. Question number 2. Solve it. I give you 5 minutes. Yes, Namay. Namay, are you asking anything?
Yes, sir. Good evening. I had a small doubt.
Yeah.
So while the other students are busy doing question two, I had a small doubt.
Yes.
Sir, could you confirm the pattern for n term?
There are 5 questions in the end term, and all questions are compulsory.
Sir, I understand that. Sir, do you mind sharing the week breakdown for that?
Week breakdown. If we are talking about the week 9, 10, 11, that is
Yeah.
cover the 40% of the particularly questions. That means two
Meaning
questions
about
out of 5.
2 questions, right?
And from week 1 to 8, there are the 3 questions.
3 questions. Sir, will you be able to provide any distribution on the basis of 1 to 4 and 6 to 8?
Mm,
1 to 4 and 5 to 8, my bad.
1 to 4 and 5 to 8. Actually, 1 to 7, if you are talking about, okay, I will provide you the distribution for 1 to 4 and 5 to 8 also. Okay, but till now I have just distribute that one on the basis of quiz 1 and quiz 2 that you already covered, that is the 60% content, and then that is not covered in the quiz part, week 9, 10, 11, that is the 40% covered.
Can we say quiz 130, quiz 230, and the remaining 40?
Not exactly same. I will just confirm that one. In the next class, I will confirm that one.
Okay, so because you know why I asked this was the content after quiz 2, right? 9, 10, 11, 12. That is
9,
highly,
10,
oh, sorry, 12, 12 doesn't exist, right? 9, 10, 11. That is highly, you know, it needs to, we need a data sheet, we need to look up stuff and then we need to answer.
yeah.
So I'm assuming the data sheet will be provided to us, is
The
it?
data sheet is provided to us, either the content, the data that is required for you, either that will be provided to you. Okay,
Okay,
not
okay.
completed data sheet. The data that is required to you, that will be provided you in the table form, or maybe the some particularly papers that will be provided to you. Okay, any particular thing, but it is provided to you.
Okay. Right, right. Understandable. And sir, one last thing.
Yeah.
Actually, last time we had a meet with Andrew sir. He was taking some of our, suggestions. This term, our bonus is two, right? Like other terms. So he was while he was taking suggestions, there was one suggestion that popped up that he said he would incorporate. That was if there could be a bonus question provided in end term, right?
Bonus
So
question quantum, what is the meaning of that one?
yeah, I'll tell you. So it's like a question that if it's not compulsory, but if you attend, you may get extra marks, like extra 2 or extra 3 marks out of 100 in your final T score. This is what we suggested him, and he did mention that he'll look into it. So if you could just discuss the same with him, it'll be great.
Uh, that is not communicated to us by them, Andrew sir.
Do you suggest me to mail him?
Yeah.
Do you suggest me to mail him once?
Uh, but that anthem paper is already decided. That is already on the teachers portal. So if you mail them, there is no particularly improvement in that part, because we have already given that particularly anthem paper. It is
Okay.
submitted. The last date for the submission of the anthem paper is around 20th of March. Okay, so
Oh,
every
I
paper will
see.
be that on the portal, or basically on the TCSIN portal.
Uh, okay.
So if you basically,
So we can't do anything about it now.
yes, but I think without any question, you are also getting the bonus marks, no?
Sir, but that's only 2 marks, right? Earlier it used to be 5.
Uh, 2 marks from that, and then after that, again, if you are in the range of nearby to the higher grade, so it will be upgraded. Like for example, if you are after bonus marks, if you are getting a 78 marks, so it will be automatically converted to the 80, and your grade will be according to the that 80. As
Sir, I am
I am
afraid
not
that does
sure
not
about that one,
happen. No, sir.
but
I mean, that does not happen.
that does not happen, because in particularly one T score, like for signal system, I saw that thing.
Sir, I request you to kindly consider my roll number for the same, if that is possible.
Uh, if it is possible, so possible for all, not a particularly roll number. Okay, so if any rule will be applicable, that is applicable for all.
Okay,
Don't worry
sir.
about it.
Anyways, I'll
Okay.
just mail him asking what can be done this term for bonus.
No, exactly. There is no particularly. We will discuss that one. Okay, once final your final T score will be there. After that, if we are getting some particular student who are getting a nearby range of the higher grade, so we request them to kindly provide you one or two more bonus marks, so they will improve their grade. Okay, we can do with this thing with the, okay.
All right, sir. Got it.
Because final grading will be only dependent on the course instructor and the faculty who are taking the subject. So we request, we are giving them the final, this is the final marks. After that, if you are like for example you have a 79 marks, okay, and we know that after getting 80 marks you are getting a one higher grade. Okay, so we request to the professor that sir, can we increase 1 marks or 2 marks, so that is all up to Okay, but
Right,
generally,
sir.
the professor will be accept this request.
Got it.
Okay, so you are getting
Understand.
a high result.
All right, sir. Got it. And sir, one more thing. So in today's class, we are doing a revision question or something.
Yeah, today if you have any doubts, you can ask me. Otherwise, we are doing some previous end term question paper.
Okay. 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 Great.
Just question number 2.
Not getting the idea, sir, how to solve it.
Hmm?
Not getting the idea how to solve it.
Now you are getting the idea how you solve this one.
No, not getting the idea.
Okay.
If you give some hint, then we will try.
So what we have to do again here in the particularly we apply the KCL. Like for example, we are considering this is the V1 voltage. Sorry, this is the V negative voltage. This is the V positive voltage. This is the Vx voltage. Okay, so like for example in this week 7 we have done this question. If you remember that R2, and after that R2 there is one R3 that is connected between the V out and the this particularly node. Okay, and then after that R4 connected with the Vx and grounded. So similar type of question is this one. Okay, similar type of question is this one.
Okay, sir.
So just thing is that you have to apply the KCL. Okay, the current that is coming from this one, it will be going in this way. Okay, so if we apply the KCL at this point, you are getting the V minus voltage. After that you apply the KCL at this point, you are getting the current that is coming in this way. It will be going in this one and this one. Okay, now current that is coming here, it will be go to the grounded. Okay, it will be going to the grounded. So the equation for the Vx is what? V minus minus Vx. The current that is coming from V minus terminal upon R2, that will be going in two branch. One is the Vx upon Rf plus R2. Through these two resistors, it will be going to grounded plus Vx minus V naught upon R2. Vx minus V naught upon R2. Okay, this is the first equation you can draw. Similarly, equation you can draw with the V negative. Okay, try to solve it.
Sir, if this is Vx, then the voltage across the R2 and R2 is also Vx, no?
What is the
Where
meaning of?
means where the RF is connected. This voltage is also Vx, no?
Yeah, RF is connected on this terminal, and through this one it will be go to the R2 to download. Yes. I will solve it.
Sir, the equation for the V positive is V2 plus V2 minus Vx upon R2 is equal
V
to V.
positive is this one. How you calculate the V positive and V negative? Okay, consider the one time as a V1 as a 0 and second time V2 as a 0.
Sir, can you please solve this now?
Okay. So first thing is that we consider that only the V1 is present. Okay, this voltage is 0. Okay, V2 is 0 and V1 is present. Now, at this point the voltage is 0. So what is the output voltage? If we apply the superposition theorem, consider this voltage is 0. So the voltage, so no current will be flowing from this one, no current will be flowing from this one. Okay, so it is a V out is what? minus V1 into 2 times R2 by R1. Okay, that is V1 upon 2 times R2 by R1. Okay. When we are considering V2 voltage, so here V1 is 0. What is the feedback circuit is the voltage at this point is what? V2 times 2R2 upon R1 plus R2. So the R1 plus 2R2. Okay. This
So
was
there is no role of RF in the positive part.
RF. Oh,
That was the confusing part.
wait a minute. It is a T network. ये कहते हैं ऐसे T network. Let us apply the. I think that is a better way that we can apply. What we can do is we can do one thing is we can apply the KCL. Yeah, that is a better way. So we are saying that this is a V minus V plus. Okay, that is a Vx or that is a Vy. Okay, so V1 minus V minus upon R1 is equal to V minus minus Vx upon R2 plus Vx minus, sorry, only this is the equation part. Okay, only this is the equation part. If we apply the V negative terminal, if we apply the V negative terminal. Now if we apply the Vx terminal, so that is a V minus minus Vx upon R2 plus either we say that the current that is coming this way, it will be going in this direction and it will be going this direction. So we can say V minus Vx upon R2 is equal to Vx minus Vy upon Rf plus Vx minus V0 upon R2. So this is the equation number 1, equation number 2. Okay. Similarly, if we apply the Vy terminal, so what is the Vy terminal? So V positive minus Vy upon R2 plus the current that is coming from this way, the current is coming and the current is going in this direction. Plus Vx minus Vy upon Rf is equal to Vy upon R2. This is the equation number 3. And finally, the equation number 4 is what? V2 minus V plus upon R1 is equal to V plus minus Vy upon R2. This is the equation number 4. So we have written the 4 equation. Now with the help of these 4 equation, we eliminate. Okay, we eliminate all that intermediate node voltage Vy, Vx, V positive and V negative. All the equation will be in the terms of V0, V1 and V2. Okay. Now can you solve it? Yes, so we have written 4 equations. First with respect to the V minus, this is first equation. Second is with respect to Vx. Third is with respect to the Vy, and fourth is with respect to the V plus voltage. So we have written 4 equations. Now the question number 3. I think that question you already solved.
Yes, sir. 3 and 5 we can solve.
Fourth question I think already solved. Hmm. Fifth question, no issue with that. Fifth question also. For the seventh question, sixth I will tell you. Seventh question, the self-resonating frequency for the each capacitors. So there are two capacitors C0 and C1. The formula of F is equal to 1 upon 2 pi root of LC. Okay. Now C0 will be represented by the form of ESL, SL0, C naught and ESR naught. Okay, what is the ESL naught is 25 nanohenry. What is the ESR naught is 0.2 ohm. What is the C naught is 10 microfarad. Okay, so you are using the L naught value and C naught value to calculate the first F naught. Second, you have to calculate the F1, that is equal to 1 upon 2 pi root of L1 C1. Okay, now for the 1 microfarad, C1 is 1 microfarad and L1 is what? 10 nanohenry. Okay, so you are getting the value of C1 and L1 and C1. Now plot the effective resonance of the two capacitors connected in parallel as a function of frequency. Okay, now you have to plot a curve. Now, for example, you are getting the F naught value. The F naught is 10 kilohertz, and with respect to the F1, you are getting a 20 kilohertz. For example, okay. So, what is your response? For 10 kilohertz, for 20 kilohertz. Okay. You have to draw two particular graph. One is graph is this one, and second graph is this one. Okay, so these are the two graphs with respect to the impedance. One graph is the ZC and one graph is the Z out. Okay, and so equivalent is this one. Now these two peak will be arises at a 10 kilohertz or a 20 kilohertz. Okay, so this is the effective impedance plot as a function of frequency. Here you are getting the frequency F, and here you are getting a value of Z. Okay. Now the question number 8. Now mark the sign of operation amplifier. If you apply a positive terminal here, so because of this positive terminal and this negative inverting element, your this part will be the negative feedback. Your this one will be the negative feedback. So this is your sign of the operation amplifier. Okay. Now plot V out as a function of RFB. So this become a plus, minus. Now 1 volt. So 1 volt here. 1 volt here. So what is the value of V out? V out is what? 1 plus RFB upon 100K times V times V. So V out is equal to 1 plus RFB upon 100K times V. So if you calculate the V out as a function of RFB, so when RFB is 100K, you are getting a V out as a 2V in. V out as a 2V. Okay, if you are getting a 200K, it is a 3V. If you are getting a 0, so it is a only V. Okay, so when you make this point, you will be getting this type of graph. Okay, you are getting this type of graph. Okay, so plot V out as a function of RLB. Assume that there is no load current is applied. No load current is applied, that means there is no load. Okay, if you consider that there is a one RL, so from that one there is a IL current will be flowing. Okay, now consider RL is 0, so IL is also 0. What is the maximum V out achievable at no load current? So what is the maximum achievable V out? Thus, so V out is always less than or equal to maximum supply voltage. Okay, operation amplifier output voltage doesn't go beyond the supply voltage. Now, The voltage difference between the voltage source and V out is less than 200 volts when the output voltage difference between the load current of the system is 2 milliamps. Okay, so they are saying the maximum load current is what? IL max is 200 milliampere, and what is the ZL? ZL is 0.5 ohm because it is a inverting element MOSFET and the impedance of that particularly inverting amplifier is 0.5 ohm. So what is the voltage drawn across the load? So VL is what? 200 into 10 raised to power minus 3 multiplied by 0.5. So it is a 0.1 volt. Okay, 0.1 volt. So what is V out? V out is nothing but V in minus VL. So that is 4.2 minus 0.1, that is the 4.1. Okay, so maximum V out achievable at full load current. Okay, if they are saying the half load current, so what is the meaning of half load current? The full load current is 200, so half load current is 100. I max is 200. So what is the VL is the 100. Why? Because half load current multiply by 0.5, so that is the 0.05 volt. Now 4.2 minus 0.05, so it is a 4.154 if it is given the half load current. If it is given the half load current. Now in the question it is given the full load current, that means 200 milliampere all current will be passing through the load. Okay, so this is the question number 8. Now if you are talking about the question number 7, so question number 7 says that it is a R set, R term. Okay, so if you see in the data sheet, the K set is 540. If the current is question given in the question, it is given the 1 ampere current. Okay, charging current is 1 ampere. So 1 ampere is that is 1,000. Okay, that is 1,000. So if 1,000, so we are taking the typical value of 540. So K set is nothing but I out is nothing but K set upon R set. Okay, R set. Asking in the question what is the R set? That is K set upon I out. K set is 540 ampere ohm divided by 1 ampere. So if it is ampere and ampere cancel out, so the value of K set R set is a 540 ohm. Okay. Now part B is that you have to calculate the R term. So here if you see the formula, percent term is equal to R free term upon K term. Okay. So R free term is equal to percent term multiplied by the K term. What is the value of K term? 200. Why we are choosing a 200? Because it is showing that fast charging 10 to 50%. So if you see the termination current in the question, it is given the termination current is 1/10. That is a 10%. Okay, 10%. So it is if it is a 10 to 50%, so we are taking the this value 200. So K term value is 200 multiplied by the 10. So that is the 2000 or 2 kilo. Okay, so R term is 2 kilo. Clear? Now, if the system uses a 1000 mAh battery, that means 1 ampere hour battery that will be charged with the 1 ampere. So, how much time it will be take? It is a time taken the 1 hour time. So, what is the charging time? 1 hour. What is the charging time? 1 hour. Okay. Any doubt?
No, sir.
So now you try by your own, and if you have any doubt, you can ask in the next class. No issue with that. But try your own. I just give you the all the idea. We question 1, 2 idea I have given, 3, 4, 5 you have already solved. Okay. Similar question of 3, 4, 5 you have already solved. 6, 7, 8 I am giving you the idea. Okay, just try by your own, and if you have any doubt, you can ask. Yeah, someone is writing. Sir, can you please explain the question I asked you in the Google chat? Okay. So yes. So yes, can you tell me what is your doubt in that one? Yes. Yes, can you hear me? Yeah, I guess solve the question the same way you solve the graded assignment. Okay. The thing is that in the graded assignment, if you see the question number 1, okay, if I am talking about the week 7, question number 1, I follow all the steps. Okay, and from that one I just use the formula v naught upon vi, that is in the terms of r4 or something value. Okay, now I use that formula, we calculate the v naught upon vi. Now I use this formula in my question number 4. In question number 4, okay, put the value of r4 and calculate the v naught upon vi. Is it clear? Any doubt in that one? Okay, now if we are talking about the quiz 2 part, now in the question number week 1 week 7, if we are talking about question number 1 to question number 4, we are taking the r1 is equal to r2 is equal to r3 is equal to r. Okay, so we solve this particularly question number 1 to 4 by this assumption, by taking all this one. Now in the quiz 2, what we are doing, we are taking the r1 is equal to r2 is equal to r3 is equal to 2r. If we are using a 2r, my all calculation will be changed. Okay, calculation is changed. Now what you do, you are using the same formula v naught upon vi according to my graded assignment. You are using that one, but that is wrong. Why? Because now r1 is equal to r2 is equal to r3 is equal to 2r. Okay, so completely the v naught upon vi formula is changed. It is not similar to the graded assignment. You are using the same formula as respect to the graded assignment. Put the value of r4 and calculate it. But it is not a similar formula v naught upon vi. Okay, so this is the problem that you are facing.
Sir, can you please also provide the mock for
The
the end term? Mock for the end term.
mock for the anthem. Okay, I will ask the team to basically release the mock.
It is similar to the end term technique, sir. The mock will be
No.
similar.
Mm, okay, I will do one thing is I just modify some questions. Okay, so maybe probably till Friday you will get your mock test. Okay, this Friday.
Okay, sir. Okay, sir. And sir, one small request regarding the extension for the lab. Sir, it is
Better that you can write on as support. Okay, I just inform you, just CC to me. I just inform the support team, but the extension will be basically when you are requesting to them, they will ask to me, and after the on your behalf of your mail ID, I just tell them you just extend the deadline. Okay, but all decision will be done by them. They ask me that can we extend the deadline, but so that better is that you can directly write a mail to the support team and CC to me. Okay, because the portal will be handled by the support team. They will extend the dates. They will ask or confirm with us. Okay, but they will extend the date. So better you just drop a mail to the support team, CC to me.
yes, sir. That's why I am asking. But it is very time consuming.
Okay, no problem with that one. You just send a mail to support team. Okay, the particularly CC to me.
After the end term, I am asking for the after the end term we can do the lab, submit the lab.
After the end
From
term.
experiment 5, from experiment 5, 4 we can do this in this week.
Okay. So for 5 and 6, we are giving a deadline of after the end term.
Yes, sir.
Okay, just write a mail to them. Support team and CC to me. We can do one thing
Okay,
is
sir.
that we can extend the deadline 2 or 3 days after the end term, 15th. Okay, but that is a hard deadline. After that, maybe no extension will be provided. Okay, but we will discuss this with the professor.
Okay, sir.
Any other doubts? Thank you all.